Okay guys, let's start with this basic problem, and that is log tan 5. We actually have to find the value of this, right? So we have to find log tan 5 multiplied by log tan 9 all the way up to log tan 61. Now, if we're going to be a bit more focused about this problem, you may think at the first place that how can I possibly know the value of tan 5? Because mathematically we know the trigonometric ratios of some angles, but we actually don't know what actually tan 5 is equal to. But if you're going to see this series goes like 5, 9, tan 9, then there will be tan 13, tan 17, but there will be a term in between that will be log tan 45 degrees. That means this term has to be there somewhere in between. That means, why is that important? Because you can realize that if this term will be there, actually this term is there, you can say that log tan of 45 is mathematically 1. So I can say that this is log of 1. Now simply it means, what should I raise 10 to in order to get 1? That means I should raise 10 to the power of 0. Now the value of this term will be 0. So there's a term in between there whose value is mathematically equal to 0. That means 0 multiplied by all the terms will end up being 0. So that means the whole value for this whole stuff will be equal to 0. Okay? Let's move to the next problem. Unity. Yeah, unity. We're going to talk about unity now. Now, simply, what does it mean here? We have the form of log like this, log an, right? Now, if base here, which is a here, if base and the argument inside thing n are both greater than 1. What I'm talking is this, is a is greater than 1 as well as n is greater than 1, then the value for log will always be a positive number. Now what I'm talking about is this. Now suppose we have this log base 2 4. Okay, it simply means what should I raise 2 to in order to get 4? If I want to write it mathematically, let's write it in the compact form. This means this. I raised 2 to the power of x and I got 4. Let's suppose I raised 2 to the power of something which actually I don't know what I have to raise to. Now you can logically think about it that 2 has to be raised to the power of 2 and I will get 4 on the left side as well. So that means x here should mathematically be 2. Now the value of x here that came out to be should be the value of this, like, right? It simply means 2 has been raised to the power of 2 and I got 4. But most important thing here to realize is that this number on the right side is a positive number. That simply means if right side is a positive number, the base and the inner thing will be greater than 1. Now it can be lesser than 1 as well. But in that case, we're going to talk about it here. Okay, we're going to now talk about that. So simply it means if this and this are both greater than 1, the value will always come out to be a positive number. Okay. Now what if they are lesser than 1? If both are lesser than 1? Okay, let's see how it goes. Okay, let's see, like this, log base 1 by 2 and 1 upon 8. Now it simply means 1 by 2 has been raised to the power of x and I got 1 by 8. So it can mathematically be written like this, 1 by 2 has been raised to the power of x and I got 1 by 8, right? Mathematically, if I want to manipulate it, I know that 8 can be written as 2 cubed and I bring it in the numerator, it becomes 2 to the minus 3. So on the left, I can bring it in the numerator as well. This becomes 2 to the minus x because this is 2 to the x. In the denominator, bringing it in the numerator becomes 2 to the minus x. This can be written as 1 upon 2 cube, right? This 2 cube can also be brought into the numerator. So this becomes 2 to the minus x is equal to 2 to the minus 3, right? Now I know if bases on both sides of the equality are same, I can directly compare the powers. That means minus x has to be equal to minus 3. Minus cancels out, x has to be equal to 3. Now the value that came out to be here is a positive number. So that means the value later on for this problem is 3. Now you can also see one more thing here. Here the base here, which is a here, it is lesser than 1. Not only that, the inner thing is also lesser than 1. Because 1 by 8 is lesser than 1. So n here is also lesser than 1. Now again you can see that the base and the inner thing both are lesser than 1. If that is also the case, the value that will later on come out to be will also be a positive number. The conclusion simply is if the base and the inner thing both are simultaneously lesser than 1, the value for that log will be positive. Now if the base and the inner thing will be greater than 1, okay, both simultaneously are greater than 1, simply in that case also the value of the log will be positive, right? So we got to do those two things. Now, if you're clever enough, you must say, wait a minute, what if they will be on the opposite side of the unity, okay? We're going to discuss about that problem. Now, what I'm talking about is this. What if they are on the opposite sides of the unity? Let's see the example. What I'm talking about is this, yeah, perfect example. Log base 2, 1 upon 32, right? Now, you can see that the base here, which is 2, okay, a is greater than 1 because 2 is greater than 1. Not only that, if you talk about the inner thing, which is n here, it is lesser than 1. 1 upon 32 is lesser than 1. Now you can see that the base is greater than 1, but the inner thing, which is n, is lesser than 1. Now both, one is greater than 1, another is lesser than 1. So they are on the opposite sides of the unity, or they are on the opposite sides of 1. Okay, now I want to check out the value of this thing, okay? So that means 2 has been raised to the power of x, 2 has been raised to the power of x, and I got 1 upon 32, 1 upon 32, okay? Logically, 2 to the x equals to, this 32 can be written as 2 to the minus 5, and bringing it in the numerator, it becomes 2 to the minus 5, so I can write it like this. So 2 to the x is equal to, bringing it here, becomes 2 to the minus 5. Okay, now again, on both sides you can see bases are equal, so I can compare the powers. So x should be equal to minus 5. Now what the important conclusion that you should know here is this. Now you can see that this and this are on the opposite sides of unity, and the value came out to be negative. Now the conclusion is, if the base and the inner thing both are on the same sides of unity, whether they are greater than 1 or they are lesser than 1, but they have to be lesser or greater than 1 simultaneously, then the value for the log will be a positive number. Now if the base and the argument or the inner thing will be on the opposite sides of the unity, it simply means the value that should come out to be here will be a negative number, right? Okay, let's see one more example. Okay, let's keep proceeding. Let's see, log root 749, log root 749, right? Okay. Now, if I talk about the base here, a is root 7, and you can see root 7 is greater than 2, but it simply is greater than 1, right? Okay. Now, if I talk about 49, 49 is also greater than 1, so n here is also greater than 1. And you can see that a, which is base, and n, which is the inner thing, both are on the same side of unity. The value that should come out to be here should be a positive number. I'm going to check it out. That means root 7 has been raised to the power of x, and I got the value 49, right? Okay. Now root 7 is actually 7 to the power of 1 by 2, because root can be written, root is actually 1 by 2. So it is 7 to the power of 1 by 2, writing 1 by 2 instead of root. So x is equal to 49. Okay. So if we have a power of a power, we can multiply them together. So this becomes 7 to the power of 1 by 2x, right? Equals to 49 can be written as 7 square. Now again, you can see the bases on both sides are equal, so I can compare the powers. So that means 1 by 2x has to be equal to 2. Okay, bringing this 2 on the other side becomes a multiple. So x has to be equal to 4. And you can see the value came out to be a positive number. Simple. And it should have been a positive number because the base and the argument both are greater than 1. Okay, let's see one more. Yeah. Log base 10, 0.001, right? Again, we can write it in the exponential form. I can say 10 has been raised to the power of x, and I got 0.001. Okay, again, this actually can be written as 10 to the power of x. In the fraction, it can be written 1 upon 1000. Okay, 1 upon 1000. Okay, now this 1000 is actually 10 to the 3. So I can see that 10x equals 1 upon 10 to the 3, right? Now 10 to the 3, bringing it in the numerator. So again, left side is 10 to the x equals 10 to the minus 3, because it was 10 to the 3 here in the denominator. I brought it into the numerator, and it became 10 to the minus 3. Again, on both sides, bases are same, so I can compare the powers. So x has to be equal to minus 3. Now you can see that the base here was a was greater than 1. And the argument inside thing was lesser than 1. Now you can see both are on the opposite sides of unity. That means the value that should come out to be here should be a negative number. That's what I got later on.